Believe it or not, we are still on example 1 of lesson 4, but now we're on part J. So just another possible different formatting of a question. I'm seeing x squared plus 9 equals 0. I would like to know what x is, so the first thing I'm going to do is move that plus 9, and I'm going to subtract 9. The thing about this problem is, yeah, I get an x squared, but I'm getting negative 9. 0 minus 9 is negative 9. And that's a problem, because I'm going to solve by square roots. Now remember, square roots is the opposite of squaring. Squaring is when you say something times itself gave me that number. Square rooting is to say, well, that's what the number was. So I need to figure out what number times itself is negative 9. And the negative is the problem. Because if you take 3 times itself, you're not going to get negative 9. If you take negative 3 times itself, you're not going to get negative 9. The only way to get negative 9 is 1 positive and 1 negative, which means I didn't take anything times itself. So when you solve by square roots, if you're trying to square root a negative number, that's an issue. That should be like red flag, pay attention. That's a problem. You cannot take the square root of a negative number and get a real solution. So we're just going to say that there is no real solution. Don't tell me that x is 0. 0 is a number. We're saying there is no real number we could put here that would make sense. So I'm just not going to put a number. So sometimes that'll happen. Not super common, but possible. So let's look at this one with all these negative 10s flying around. So it's kind of annoying that there's so many negatives, but the first thing I'm still going to do is try and get that squared term on its own. I'm going to do that by moving that minus 10 first. The opposite of subtracting 10 is to add 10. So negative 10 plus 10 is 0. It knocks it out, which just leaves me negative 10x squared. The opposite of negative 10 plus 10, like those are opposites. They cancel each other out. But I can't leave this right-hand side blank, so I do need to put the number 0. And that's going to matter because here in a second, I need to move this negative 10. Remember, when it's right in front of your variable, it's multiplication. And the opposite of multiplication is division. So I'm going to divide by negative 10. Now 0 divided by anything is still 0. So it didn't matter what I divided by. We got x squared equals 0. This is not the same issue as up here. I cannot square root a negative. You can square root 0. If I ask you what number times itself is 0, you would say 0. This is the one and only time where you will not get two solutions when you solved by square roots, because there is no negative 0. There is no positive 0. There's just 0. So the one solution to this problem is 0. It is the only time that we didn't get plus or minus, plus or minus, plus or minus, plus or minus. That one exception, other than the no real solution, is when you get exactly 0. The last one for this particular set of notes here. Again, previewing the Pythagorean theorem, and I can guarantee you when I give this to my geometry class, I will consistently have, 40% of the class that will consistently do this problem wrong. So what I want to point out, the structure of this problem is really similar to part I, or even part G. And if you remember from both G and I, the first thing we did was we said, well, let's get rid of these numbers squared and let's square them. Let's simplify some things. That's going to be what we do here. But the reason why this one messes with people so much is the thing I'm squaring first is 2 root 3. Now, I'm saying we're going to square everybody. So that means I'm taking this term, 2 root 3, and multiplying it by itself. And mostly when people see this, they don't want to do that. They just want to square whatever's most convenient and close to the squared. And that's not what this means. It says square everything in these parentheses. And back when we were multiplying radicals, we said, okay, well, let's multiply our coefficients. 2 times 2 is 4. Let's multiply the numbers in the radical. 3 times 3 is 9. And let's simplify. You could go ahead and do a factor tree for 9, but you would find just a pair of threes, and if pairs make perfect squares, you could have just realized, well, the square root of 9 is 3. There's no radical, there's no number, there's no prime number over here that didn't get paired up. So there's no radical. We just get a 12 from squaring 2 square root 3. But there's the rest of the equation. 2 squared is 4, and that is equal to x squared. So there's still a plus 4 every time that I was just temporarily ignoring. And that is still equal to x squared. I just don't want to write it all those times. So now I have like terms on the left side. I'm going to go ahead and put 12 plus 4 is equal to 16. And I'm going to solve by square roots because I have a term that's being squared. That will give me 2 solutions because I'm not square rooting a 0 here, so we're going to get plus or minus. You could do a factor tree if you forget that this is a perfect square. If you realize it's a perfect square, you can go ahead and say you're done. Your solution would be plus or minus 4. So again, a reminder, if you see these parentheses around this term being squared, it does not mean to just square this root 3. It does not mean to do that. That is very, very wrong. But that's the most common mistake that I see. So just be mindful of that whenever you go to do problems like